Question 19, chapter 7, mixed exercise, and really this is a nasty question. If you don't see the right thing, then you're not going to get it. And to be honest, this is the second video I've made on this one, because the first one I set off on completely the wrong track and it didn't help. So how do we spot the right things? Well, if you look at it, we've got a theta over 2 and a theta involved, and I've got a sine theta plus alpha here. So what things should we be thinking of? We should be thinking of double angle formulae. And we're using them as a half angle formula. And then also here, this thing is the r sine theta plus alpha sort of form, right? Which I think is section 7.5. And also I've got an a plus b formula thing going on here. So maybe what I need to do is take this thing. Now remember, this isn't an identity, this is an equation, right? They're telling us this is true. And I've got to show that this equals 1. So maybe they're telling me there's a hint here to start with this bit and work from there. Now, even given all that information, it is not obvious what to do at all. So if you didn't see this one, I wouldn't feel bad about it. The way that will work for us is double angle formulae. What have we? So with double angle formulae or half angle formulae, what have we got? We've got sine theta equals 2 sine theta over 2 cos theta over 2, and that's where I started. I tried to use that one and to replace this sine here with 2 sine theta over 2 cos theta over 2, and that one didn't help. And it turns out the best way forward is this one. Cos theta equals cos squared theta minus sine squared theta is the standard form of it, the one that I always remember. Oh, sorry, theta over 2 sine theta over 2. But if you look at the rest of the question, there's only sines involved. So maybe it's best to remember this as turn the cos theta over 2 into 1 minus sine squared, 1 minus 2 sine squared theta over 2. And now, this is the version that we're going to use. We've got a sine squared theta over 2 there. So I'm going to take this one, and I'm going to change this sine squared theta over 2 into something to do with cos theta. And the reason that's going to be helpful is that the left-hand side of this then will turn into something to do with cos theta, and I will have a sine theta on this side, I'll have a cos theta on the other side, and I will have something of the form, eventually if I simplify it down, a cos theta plus b sine theta. And when I get expressions that look like that, I can rewrite them in the form r sine theta plus alpha, and doing that is a standard technique. Okay, so that is the method that we're going to use. We're going to use this relationship here to turn the left-hand side of this equation into something that has a cos theta in it. We're then going to take the equation and rearrange it into this form, and then we can work from there. So you might want to stop the video and finish it off for yourself there. I'll go a little bit further. I'm not going to do the entire thing. 2 sine squared theta over 2 equals 1 minus cos theta, and then sine squared theta over 2 equals 1 minus cos theta all over 2. By the way, this version of the cos, the half angle formula or the double angle formula if you prefer, this is one of the 3 standard ways of remembering it. What you should think of here though is that we have a conversion between sine squared theta over 2 and cos theta. So you know that one thing can be converted into the other. In the same way as you have a conversion between sec squared and tan squared. There is a trig identity that links sec squared and tan squared. There's a trig identity that links sine squared and cos squared. There's a trig identity that links cos and sine squared of theta over 2. Or if you prefer, there's a trig identity that links sine squared of theta with cos of 2 theta. So that's the trick here, is realizing that when I've got a sine squared theta over 2, I can turn it into a cos theta or something to do with the cos theta, and then realizing that that will let us rewrite our equation as something to do with the sine theta and a cos theta. So the equation that we've got then, sine squared theta over 2 equals 2 sine theta. Sine squared theta over 2 can be written as 1 minus cos theta over 2 equals, there we go, sine theta. 1 minus cos theta equals 4 sine theta. So 1 equals 4 sine theta, plus cos theta. Now if I take that and write it in the form r sine theta plus alpha, and if you're not sure how to do that, then section 7.5, which you will find on page 181, will help you with that. And then once we've done that, we should find that the r that we get is square root of 17. The alpha that we get is the thing that we're trying to find. So that can be rewritten as this, and this is equal to 1 if alpha is, and I think it turns out to be 14 point something. So hence or otherwise solve the equation is the same as solving the equation square root of 17 sine theta plus 14 point whatever it is equal to 1, which is the same as solving the equation sine of theta plus something equals 1 over root 17. So we're now into year 12 territory again. Capital X equals theta plus 14 point da da da, and then you've changed your variable into a capital X, so change your limits and work from there. So that one is a standard question as well. Horrible question, I thought. Maybe you found it easier than me. I certainly found that nasty.